So what is data warehouse is, it will integrate the data from different types of sources. Okay. It will integrate the data from different types of sources. So what are those sources? It can be a database, or it can be a CSV file, or it can be a flat file. Right? Flat file are nothing but text files. Okay. And it can be some XML files or some JSON files. So anything. You will read the data from some source. Okay. Or it can be streaming data. Now we have the streaming sources, right? So as soon as the data is getting generated, you will automatically load the data. So these are different types of sources we have. So from all of this, it will integrate. That means it is getting the data and it will do the modifications to the data, or it will do the cleansing to the data. Okay. Then it will load into data warehouse. It can do the cleanse. Okay. Cleansing of the data, or cleaning of the data, you can say. Okay. Cleaning of the data, and then transforming it into proper format or into the usable format. Okay. It will transform the data, it will integrate the data from different sources, and when it is doing that, it will clean it and it will transform as per your requirement, and then you will load the data into the data warehouse. And which type of database it is? It is an OLAP. OLAP is nothing but analytical processing. Okay. Then analytical processing. Okay. Data warehouse comes under OLAP because it will store the aggregated data. Aggregated data. Okay. Aggregated in the sense you are converting it. Aggregated, again, don't be confused. Okay. Let me not use that word. Aggregated is not like, okay, you will be doing some aggregations on top of the data and loading the data. It is not like that. You will be denormalizing it. Okay. Based on your dimensional modeling techniques. Okay. There is a concept of dimensional modeling. Okay. I'll tell you what are the dimensional modeling techniques are there for you. Okay. Based on dimensional modeling techniques, you will be loading the data into your database, into your data warehouse. So data warehouse also is nothing but a database, simple database, but the way it stores the data is different. Okay. It is also a database, but why you call it as a data warehouse? Because the way it stores the data is different. Okay. The way it stores the data is different. Okay. So normally, what will be the sources for your data warehouse? Let's go to an example. Okay. What are the different sources? Okay. Or you can take an example. Okay. For example, you have a restaurants are there. Okay. Okay. Restaurants are there. Okay. Restaurant. So you can think like, okay, McDonald's. Okay. McDonald's is there, or some stores. Okay. Anything is there. So, or you can think of KFC, anything. Okay. They will be having different branches, right? What they will be having? Multiple branches will be there for them. Okay. Multiple branches is there. So you will be getting the data from each and every source, right? You will get the data from each and every branch. Each and every branch, right? Because so people will come and purchase something in that particular branch. So all that information they will store somewhere, right? Like they will be doing campaign. You are getting some messages from KFC or some other restaurants. Okay, some offers are going on, and if you want to purchase this thing, and you can come and purchase, or some festival offers are going on, and you are getting it for very less price, or 1+1 offer is there. So all those things they are doing. How they are doing? Because they have your data. How they are getting the data? You went to that place somewhere and you gave your details over there. That's how they will be getting the data, right? For all of that, they have to store that information. Even if they don't want to do campaign, they want to see how the business is running and all of that. So what you are purchasing and everything will be tracked into the database. So here, what will happen? All the data will be tracked into the database or some file. Okay. So what we call this data is OLTP. This is transactional processing data. Okay. Online transactional processing. Okay. Because this is as soon as the transaction is happening. Okay. Okay, as soon as the transaction is happening, data is getting stored. Okay, whenever you are storing the data at each and every branch, we'll call this as a OLTP databases, because data is getting stored as soon as it is coming, and it is not in the denormalized format, or it is not in the properly used format. Okay, each and every transaction, and we call these databases as OLTP databases. Okay, transactional databases which are storing transactional data, okay, or OLTP system. Okay, in these OLTP systems, do you want to fetch the data from that system? No, right? Mostly your requirement is somebody is coming and somebody is purchasing some of the items from your store, or it can be a restaurant, anything. So the data will get stored over there. You don't get it from there, right? You don't try to read the data from there. So major purpose of OLTP system is OLTP system is
storing the transactional data.
yes, storing of the data. Okay, storing of the data. So if your OLTP system provides a way for the easy storage point of view. Okay, you should be able to store it easily. Okay, within a short span of time. Okay, within short span of time, you should load the data. Okay, you should load the data. If it is taking time to load the data, then customers won't wait for you, right? Because as soon as they enter, it should go and sit into your database. If it is taking around 2 minutes, you can't wait at the counter. Okay, I have to wait for 2 minutes and all of that. It won't happen, right? So storing of data should happen very fast. So the purpose of whenever you are designing any OLTP system, okay, you are writing to the database. Okay, writing, this is what we call it as writing into the database. Okay, not reading into the database. Reading is nothing but you are getting it from there. Correct? For example, you are writing some select statement. This is what is reading, right? You are trying to read the data from here. So insert is nothing but
Insert, right?
writing. Okay, insert is nothing but writing into the database. Okay, and update is nothing but writing into the database. Delete is also writing into the database.
Right.
But in a OLTP system, what you will mostly see, for example, even if you consider your example, insert, we will see mostly insert. Okay, 90% of the cases it will be insert only. Insert operations are nothing but writing. Okay, so this writing should be very fast. Okay, so this is what is OLTP. Now you got the difference between. Now you got what is OLTP.
Yeah.
So it will store transactional data, and in the transactional data, okay, writing should be very fast. Reading, because we don't use much in terms of reading for the OLTP system, because everything, whatever the transactions are happening, you have to store that information. Okay, so OLAP is nothing but online analytical processing. Okay, analytical processing. So as the name suggesting, it is used for analysis purposes. Okay, it is used for doing some analysis on top of the data. Okay, doing analysis on top of the data. Okay, so if you have to do the analysis on top of the data should be cleaned, right?
Yeah,
data should be cleaned. So you should not get the data in some random way. Okay, I have some long file with 100 columns or 200 columns. So how will you derive insights, or how will you analyze that data? Right? So for example, you have here around 10 columns, it's fine. But if you are having around 100 columns for each and every customer, then it will be very difficult to get something out of it, right? So what you will do in the OLTP, data will be cleaned, and you will, okay, you will store, you will clean up, okay, your data will be clean, and you will be storing whatever is required. You don't put each and everything into it. You will just store whatever is required for your business. Okay, That is what we call as business requirement. Based on business requirements, we'll design the system and we'll just pull in whatever is required. Okay. So as you are using it for analysis purpose, which should be faster? Reading should be faster. Reading should be faster because you have to get the data. Then only you will be able to do some analysis on top of this data. Okay. Then only you will be able to do some analysis on top of this data. So writing may not be that much faster, but reading should be very faster. Okay. That means getting the data from your data warehouse, because OLAP system is nothing but a data warehouse. Okay. Clear?
Yeah.
Now you got the difference between OLTP and OLAP.
Yeah.
Okay. What is OLTP? Most of the transactional data will go into your system. So here transaction will try to happen most of the time, because as soon as a customer is coming and they are doing something, that information will go into the database. Okay. So what we have discussed about data warehouse, data will come from multiple sources. It can be database or it can be files and everything. Here, for example, in your example, you are storing the data into some of the databases. So those databases, whenever any transaction is happening, if you are storing the data, then we'll call them as OLTP systems. And if you are converting the data and as per the business requirement, if you are storing it, then we'll say like it is an OLAP system. Okay. So if you want to put this into diagram, so what will come? So you will be having different databases or different files. Okay. You go here. Okay. So let me take one database. These are OLTP. Okay. These are OLTP systems. Okay. One or two multiple systems will be there. Okay. Okay. OLTPs are there. Okay. OLTP1. Okay. Your KFC or anything, any store one, from that you are getting the data. Okay. From two, you are getting the data. Okay.
Yeah.
Okay. And then from files also you can get the data, right? So from files also you can get the data. What is where is the similar file here? Let's see. From different documents you are getting the data. Okay. From different files you are getting the data, and you will be storing all of this information into
Database.
Yeah, so all of this information you will be storing into a database. Okay. All of this information you are storing into a database. How it happens will come here. Okay. So let's do this. In between this, what you will have an ETL which will do the transformations, because you have to do the transformations to your data, right? So ETL can be Informatica or SSIS or Talent, anything can be there, right? Any ETL tool. It is not like only one ETL tool. It is based on your organization. You can decide on which ETL tool you want. Okay. So it will get data from all these sources.
Multiple.
Yes, it will get the data from multiple sources. Okay. And it will do the transformations on top of the data. And then what it will do? It will push into the data warehouse. It will push into the data warehouse. Okay. This is data warehouse. This is how the structure will be. Okay. So what I have mentioned, database or data warehouse, both are same. It is just like the way you are storing the data is different. That's it, right? So database or data warehouse. Okay, both will have tables only. Okay, inside the tables you will have records. Okay, rows and columns will be there. Okay, rows and columns will be there, but there is a difference in a way you are storing the data, or there is a difference in a way in designing the databases. Okay, difference in designing the database. Okay, OLTP is nothing but in terms of designing means writing should be faster. Okay, writing should be faster, or reading should be faster. Okay, reading should be faster. And your OLTP is nothing but mostly you will have raw data, right? Because as soon as the data comes in, it will go and sit there. OLAP is nothing but transformed data. Okay, you are doing some changes to the data and then you are storing it. Okay, got it?
Yeah.
Now you have to convert the data into some proper format, right? So further, what you will use, there are different techniques. You'll call them as dimensional modeling techniques. Okay, dimensional modeling techniques are there. So the first one is, okay, first one is Snowflake, and then, okay, star schema, and then Snowflake schema. Okay, star schema, and then Snowflake schema. Okay, two different types of dimensional modeling techniques will be there. So here you got, so is there any difference between database and data warehouse? In terms of looking at, okay, tables and all of that, it is similar. But in terms of how you are storing the data, what type of data you are storing, that's where the difference will come. Okay. Now, in order to design the database, you have to follow. So how you are designing your tables, based on that one, you will call it as a star schema or Snowflake schema. Star is nothing but, okay. So before going here, okay, let me tell you two tables. Okay, in OLAP, tables are divided into, okay, tables. Okay, tables, we call them with two different names based on what type of data we are storing. Based on what type of data we are storing. One is dimension, another one is dimension table, fact table. What is dimension? It will store the characteristic data. Okay, it will store characteristic data. It will store numerical data. Numerical data. Numerical or measured. Okay, numerical data or measures data. So what is characteristic data? For example, if you go here, you have first name, last name. Okay, all this is characteristic data, you can say. Okay, how you can say characteristic data? If it is, okay, dimension is nothing but, okay, dimension is nothing but it will give information about the particular object or particular entity. You will call them, these tables as also an entities. For example, customer entity is there. So it will give information about customer, right? So if customer table is there, then it will give information about customer, like what is his name, what is his designation, like that, and what is his phone number. So it is related to the, it is giving the information related to that particular customer. That means based on your entity name, you can identify, okay, what kind of data will be there in that, and based on the data which you are storing, you can say whether it is a dimension or a fact. So here you don't have any numericals. For example, we are talking about KFC, right? You are going ahead and then purchasing something. So your details are like some dimension data. Okay. And then what is fact data? Whatever you are purchasing, okay, whatever you are purchasing, that is fact data. This is, we call it as a numerical information. Okay, numerical or measures, because here what you will have, here it will tell what product you purchased. Okay, what product you purchased, when you purchased, okay, when you purchased, what quantity you purchased, okay, what quantity you purchased, okay, and price of the product, price of the product. So here in dimension, will you see any repetition? Do you see
No.
any repetition here? No repetition
No.
of the data. Because once the customer comes, it will be one record only, right? For example, you are going to KFC and you are purchasing something. Today you went, after 10 days you went, after 20 days you went. So in the customer related information, you will see different set of data. You want to store multiple records for the same record for the same customer?
No.
No, right? So here customer data is not changing. For example, if you are purchasing it multiple times, customer data is not changing. Whereas fact data, it will change, because today you may purchase something and tomorrow you may purchase some different item. And after 10 days, you may purchase some different item and the quantity may be different and the price also will be different. So here you will see, okay, repeated data for the same customer. Repeated data for the same customer based on his purchase history, based on his purchase history, right? Here what you will have,
No
only
repeat.
one record per customer, only one record per customer. Unless there is a change, you will go ahead and change it, but mostly there won't be a change to the customer. 90% of the time there won't be change to the customer, right? So that kind of information you can call it as dimension, which can change every time for the same object. For example, here you can consider customer is an object or customer is an entity. For that customer, whatever will change each and every day or based on each and every visit, then that information will go to fact table. That means here you are, why we are saying like numerical data, because everything is numerical, right? What, how much amount you purchase, what is the quantity, and all of this. That means you will be able to aggregate this information. Will be able to, okay, you will be able to aggregate this information, like how much quantity you have purchased over the year. I can see, right? And what is the revenue I got from you over the year. So I will go and check your purchase history. I'll just group by your customer ID. Then I'll just sum it up all the price of the products that you have purchased over the year. Then I will get to see what is the revenue that was generated from you in that particular year. Okay, that's what you will call it as a measure. You are doing any aggregation, you will call it as a measure. It's a term that we'll use. When we say like numerical, that's what we are talking about. Like it is storing the information of your transaction. Here it is storing the information about you. It is characteristic information. Okay, that means it is giving the details of you or as a customer. So that's what we will call it as a dimension. And whenever you're storing a numerical information, that's what we'll call it as a fact. You got it? And again, product is a product table. For example, you're creating in our example, we are creating customer table. And now think like we have to create a product table. So will it be dimension or a fact? Product table, will it be a dimension or fact?
Fact table. Fact table.
Why fact table?
What kind of product we are purchasing and
So
how many.
So in product, will you store what type of product you purchased and all of that? Or you will store the information of the products?
Store the information.
It will have the information of products. So that means it is providing the characteristics or attributes or what is the specification of this product and all of that, right? When it was introduced, all those things will be there. So it is a dimension. Okay, it is a dimension because here you are not storing anything. So here in the fact you are storing for this customer, this is the product, this is the quantity. So whenever that information is coming, that is a fact. Here it is providing the characteristics of your product only. So product, will it change? For example, if they have 100 products, will you see any change in the list of products? Whenever they are introducing some new products, it will come. If they are deleting it, it will go from there. Apart from that, will it change for every transaction?
No.
No, right? So that's the reason we call it as a fact table. Okay. So orders is
Fact table.
a fact table. Why it is fact table? Because for an order, you should have a customer. Okay. In order to place an order, what you need? Who will place the order? Customer.
Custom.
He has to purchase something, right?
Product.
He has to purchase some product. Okay. And that product will have price. Okay. And that product will have quantity. Right?
Yeah.
And that product will have which store he purchased. Okay. So all of this information will come. So all of this, it is related to all dimensions here. Customer is a dimension, product is a dimension, right? Store is a dimension, because we have 100 stores. That information here, it will be repeated. But characteristics of that store, like store location and all of that, where you will store, it is in a dimension. Okay. It is dimension, because you are storing the characteristics. Okay, this is the store. This was established at this point of time. This is the location of the store, and this is the phone number. This is the manager, and all of that information will be there for your store. You got it now? For example, if you are taking a restaurant, what kind of tables you are creating? So based on the data, you will create these tables. Whereas whenever you are purchasing something from the restaurant, what they will do? They'll just enter your information. They'll put, okay, this is the quantity, this is the product. So what will happen in OLTP system? All of this information will go and store in a single record. Okay. This will go and sit in a single record. Out of that, we will be getting the data. Okay. Out of that, we will be dividing the data into multiple tables, and we are storing only the required information in different sets of tables. Okay. Now you got the difference between fact table and dimension table.
Yeah.
So in star schema, if you go to dimensional modeling, so we'll design how these tables will look. So based on that one, you will define it as a star schema or snowflake schema. So star schema is nothing but fact table will be in the center, and it will be surrounded by all dimension tables. All dimension tables. There is no linkage again between other tables. Okay. How it will be? First, you will have a fact table. Okay. First, you will have a fact table. For example, this is a table. Okay. This is a table. Okay. You have a fact table, and it will be surrounded by. It is a fact table. Okay. Fact table, and it will be surrounded by
multiple
dimension table.
dimension.
Okay? This is dimension table. Dimension table. Okay.
Yeah.
This is dimension table. And if you go here, one more dimension table here. Okay.
Yeah.
This is dimension table. All of this fact table is in the center, and all of these are surrounded by your dimension tables. So how it will be linked? It will be linked like this. Okay. It will be linked like this. This is called star schema. Okay. This is called star schema. Now, okay, what is Snowflake schema? What is Snowflake schema? So here you have like this, and again, this dimension table will be, okay, this will be linked to another table. Then you will call it as a Snowflake schema. Okay. Then you will call it as a Snowflake schema. That means one table is related to another table and the for structure is not coming in the star, right? Because you are going like this. Okay. It is linked to this one. And again, this dimension table also can be linked to the other one. Okay. Like this. Okay. If there is linkage between other two tables apart from fact and dimension, here you are having the linkage between fact and dimension. But if you are having the linkage between other tables, okay, other dimension to dimension or fact to fact, then you will call it as a Snowflake schema. That is the only difference. Okay. Got it?
Yeah.
This is Snowflake schema of structure, and this is star schema. Okay. Clear?
Yeah.
So these are the different concepts of your data warehouse. So what we have learned today, database, what is the difference between database and data warehouse, and what kind of data will come, how we will be storing the data in data warehouse, and when we call a database as a data warehouse or a normal or OLAP system or OLTP system. Okay. And we have taken an example, and based on that one, we have identified what are the different tables that we can create. Okay. And which table will call it as a dimension, which table will call it as a fact. All right. Now here, what tables you came up here? We have a product table. Okay. We have what tables came for you here? Okay. For example, just think like this is the star schema. Okay. Just think like now what you have, orders is a fact table. That's what we discussed here, right? Orders is a fact table. What are the different dimension tables you have?
Store.
Okay. Store. What is the other table? So what you need, if in order to place an order, what do you need?
Fact.
In order to place an order, who will place the order?
Product.
Customer. Okay, customer will place the order, and what he will purchase? He'll purchase some product, right? Some items he will purchase. So product is also a dimension table, and which store he purchased? Okay. Which store he purchased? Okay. Do we have any other dimension tables that we can create?
Price.
Quantity.
Price is again it will go with your product only, because it will be at the level of product, right? Because if you're just storing price, okay, we'll store 10 rupees, 20 rupees, 30 rupees, $100, $20, $30. So what it will give? Is it giving any meaning for you? We are just storing the price. It is not giving any meaning. So that price will be there along with the product. Along with the product. Because for this product, this is the price. That's what you can mention, right?
Yeah.
And what is the other table you have? You have date table. Okay. You will have date table, for example, because when you purchase date and all of that, you need not to store. Okay. I want to identify on the 35th of the week, what are the purchases. So what you have to do? You have to take the date and you have to identify whether the date is falling in the 35th week or not. But what will happen in the date table? Once you give the date, it will give what date is, whether it is Monday, Tuesday, or what day. Day means 11th day or 12th day or 30th day. And what is the month? What is the year? Like that you will store. For example, here, I'll just give you, okay. Yeah. This will call, this is some normal dimension table that will create every time. Okay. What will have? You will have date. Okay. You will have day. And you will have month, year, week number. Okay. Week number, weekday. Okay. Weekday. And what you will call this day number, or like over the year you will have 365 days, right? So what is the first number, second number, like that it will repeat. So it is a consecutive number, it is sequence number. It will increase till the year end. After that again it will reset, right? So like this, for example, if you're giving 1st Jan, okay, 1st Jan 2000, then what is the day? It is 1. What is the month? January. Year 2000. Week number 1. Weekday, for example, Monday. Day number is 1. Like this. So once you join with this date, you'll get all of this without doing any calculation, right?
Yeah.
Because this is another table, and you have orders table. In the order you have date. You join with the date, and you will get all of this information without doing any calculation. And it is storing the information about the date. That's the reason you call it as a dimension. Now you got it. How you have designed the database for your requirement?
Yeah.
So it is based on the business. You have to come up with what kind of tables you need. Now, on the at high level for the restaurant business, we came up with this database structure. This is the dimensional modeling. Okay.
Yeah.
Got it. And in the product also, you can have sub products. In the product also, you can have sub products, right? So sub products, if you want to store it in the product table, also you can store. Otherwise, you can create here sub product, and here you will have product. Okay. So now it became Snowflake schema type of data warehouse. Okay.
Yeah.
Got it? How you will store the data?
Yeah.
So if you are storing your product and sub product everything into this table, it is becoming kind of a star schema. But if you want to store that into some different table, again it became Snowflake schema, because your fact table is not related to the dimension tables, all the dimensions. Because your dimension table is related to again other dimension table. Okay.
Yeah.
Clear?
Yeah.
Any doubts in today's session? Or is it somewhat fast today in the data warehouse concepts?
No.
You should remember these terms, okay? So everything is a, simply remember, everything is a database. But the way how you're storing the data, how you're designing it, will make it as OLTP system or OLAP system. OLTP is nothing but transactional, okay? Whenever any transaction is happening, it tries to store the data. OLAP is most of the thing is like, it is used for analytical purposes. Analytical purposes, okay?
Yeah.
So these are the, again, types of tables are dimensions and facts, okay? And how you will differentiate dimension and fact. You got it, right? Which table you will call it as a dimension, which table you will call it as a fact. Clear?
Yeah.
Star schema. And now we have designed the structure for your restaurant scenario as well in two different techniques. One is with the star schema, one is with the Snowflake schema. Okay. Any doubts?
No.
Okay, then let's meet tomorrow. Thank you. Bye-bye.